Question 4. Part A. Find the first three terms in ascending powers of x of the binomial expansion of 1 over root 4 minus x, given each coefficient in its simplest form. Okay, so 1 over square root of 4 minus x. So that's just equal to 4 minus x to the power of -1/2, because square root means the power half, and then 1 over means reciprocal, so it's negative power. So it's -1/2. And then the formula is 1 plus x upon n, but this is 4. So we need to factorize out that 4. So if we factorize out 4, it's just 1 left, and then x will become x over 4, because if you factorize out something, the same as divided. So 4 over 4 become 1, x over 4 just x over 4. And then the power of -1/2 for all of them. So then 4 the part -1/2, and then 1 minus x over 4 the part -1/2. And then we know 4 the part of 1/2, then the power -1/2 is equal to 1 over 2. And then for 1 minus x over 4 the part -1/2, so we can just use the expansion formula. So 1 plus -1 over 2 times -x over 4. So in this case, n is -1/2, and the x will be negative of x over 4. And then plus the next one would be -1/2, and then minus one would be -3 over 2 over 2 factorial of -x over 4 squared. And then because they only want how to find the first three terms, so that's all we need. Then if we simplify, that would be 1/2. Once is the same. And then put in the calculator, -1 over 2 times by brackets negative of 1 over 4. So just treat x as 1 and then put in the calculator. So that would be 1 over 8x. And then for the x squared terms, so what I'm going to put in the calculator will be negative of 1 over 2 times by negative of 3 over 2 divided by 2 factorial, and then times by, in brackets, -1/4 square. Again, you can't put x in the calculator. So since we already know that term is x squared term, so just let x equal to 1 and then put all that in the calculator to work out the coefficient of x squared. So if we put everything in, then that is equal to 3 over 128 x squared. Now, if we expand it out, it will be 1 over 2 plus 1 over 6 in x plus 3 over 256 x squared. So that would be the simplest form. And then part B. So the expansion can be used to find an approximation to root 2. Possible values of x that could be substituted into this expansion are x equal to -14, and then x equal to 2, x equal to -1/2. And then without evaluating your expansion, state, giving a reason, which of these three values of x should not be used. So every time when they ask a question like this, it's all about what's the range of possible values of x which are valid for the expansion, and it's very easy to find. So every time the formula is 1 plus x bar n, so they always have something like mod x is less than 1. So that would be the range of values which are valid. So in this case, when we factorize it out, so 1 minus x over 4 to the power -1/2 is what we need to look at. Yeah. So in this case, negative x over 4 would be the x. So negative x over 4 modulus less than 1. So that means mod x over 4 is less than 1. So mod x has to be less than 4 if we multiply by 4 for both sides. So that means x has to be in between -4 and 4. So therefore, -14 cannot be used. Yeah, so for BI, x equal to -14 should not be used, as -14 is not inside the valid into x more than -4 and less than 4. And then for II, state giving a reason which the three values of x would lead to the most accurate approximation to root 2. So for this one, it's always the same. So closer to 0, more accurate the approximation. Yeah. So 2 and -1/2. So clearly -1/2 is more close to 0 compared to 2. So then x equal to -1/2 would lead to the most accurate approximation to root 2, as x equal to -1/2 is the closest to 0.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.